Okay, folks. It's that time of day. I will get this going around. Okay. So to summarize where we are today with names and formulas. We started this process by learning how to name ions, whether they were ions of elements or whether they were polyatomic ions. And as we did so, we also discussed how to determine the formula for ions, whether they were elemental ions or whether they were polyatomic ions. After getting into the ions, we then moved on to ionic compounds. Ionic compounds contain an ionic bond. An ionic bond is a magnetic attraction between the positive cation and the negative anions. We took those ions and we combined them to develop the formula of ionic compounds. And then we started to learn how to name those ionic compounds. After finishing with ionic compounds, we then started moving on to covalent molecules. And on Monday, we discussed the diatomic elements. Those are elements that always come in pairs or Brinkelhoff. So anytime that you come across, for instance, oxygen, all by its lonesome in nature, it will always be in the form of O2, meaning two oxygen atoms combined. The last one we went over on Monday. Monday is correct. The last one we went over on Monday was hydrogen combined with a group 15, 16, or 17 non-metal metalloid. The number of hydrogens in the formula is directly related to, or is the same as the charge that those elements would have if they were ions. So nitrogen being a 3- charge as an ion, if you combine nitrogen with hydrogen only, then it's going to require 3 hydrogens. And we also talked about how to name those. And for the most part, it's going to be hydrogen followed by the second element with the ending IBE. The only exception to that is water, H2O, which should always be water. So, now what we're going to do is we're going to move on to covalent molecules, specifically alkenes, and then binary covalent molecules. Finally, we're going to pick up with acids. And there are 2 types of acids that we will discuss. They're going to be binary acids and oxyacids. The types of acids that we're going over are called inorganic acids because there's a whole realm of organic acids. But we're going to be dealing with the inorganic acids. Now, before I'm going to go through these today, and then I want to discuss a document that I do plan to post. It's actually a PowerPoint document that may be of use to you. So let's get started. So, alkanes. Alkanes are what are referred to as a hydrocarbon. If you break down this name, hydrocarbon, you will see that it contains hydrogen and carbon. So in other words,
Alkanes are compounds of hydrogen and carbon only. Now, alkanes have a very general formula. That is C subscript N, H subscript 2N plus 2. That is the general formula for an alkane. Where N is simply going to be the subscript on the carbon. So if we have one carbon, then our hydrogens would be 2 times 1 plus 2. So the formula would be CH4. If you have 2 carbons, then the hydrogens would be 2 times 2 plus 2, or in other words, the formula is C2H6. 3 carbons, the number of hydrogens would be 2 times 3 plus 2, or in other words, C3H8. And you could continue this process. You would get C4H10, C5H12, C6H14, C7H16, C8, C8H18, C9H20, and C10H22. And that's as far as we're going to go. Okay. I was going to here in a moment anyhow. Now, each of these compounds has a specific name. The more challenging part will be C1 through C4. After that, it's not very challenging to remember the name, and I'll teach you how to get there. This very first one, CH4, is called methane. Lots and lots of things excrete methane gas. When you hear about cows excreting methane gas, they're talking about the cow excreting CH4. Just set it down. I'll get it in a little bit. The next one is called ethane. The next one is the gas that is used to heat homes. Anybody? It is propane. The next one is the gas found in lighters. butane. Before I continue, do you recognize any trend in the naming? They all end in A. They all end in ANE, just like the name of the overall group of materials. So to help you memorize 1 through 4, it's methylpropute. MEPB. Now, that trend of ane is going to continue, folks. All alkanes end in ane. All alkanes end in ane. But what happens is once you get to C5, the prefix is the same as associated with geometric shapes. So if I asked you what a 5-sided shape is called, it'd be a pentagon. Well, this is pentane. If I asked you what a 6-sided shape is called, it's not sextane, hexa. It's hexane after hexagonal. 7-sided is heptane because it's heptagonal. In other words, the prefixes are the same. What about 8-sided? A stop sign. It's an octagon, or so this is octane. This is nonane, and this is decane. Folks, when you fill up your tank with gas, it talks about the octane levels. That's what it's talking about, is C8H18. Not all individuals go over the alkanes, but I think it's important because you do encounter many of them on a regular basis. So I think it's important that you at least know what you're working with from a nomenclature standpoint. That's all there is to alkanes. So if I see the ending ANE on a word, I know it's going to deal with this formula. And so I look at the prefix, and that's going to tell me how many carbons there are. And so I just plug it into the formula and I can get the rest of the formula. If you encounter a formula that matches that general formula, it's an alkane. So it's going to end in ANE. Questions? Okay. Now what we're going to do is we are going to get into binary covalent molecules. Before I get into the binary covalent molecules, I want to ask you a couple of questions of things that were discussed on Monday. What type of bond is in a covalent molecule? A covalent bond. And how does a covalent bond form? Nope. Well, it is between nonmetals and metalloids. That's the type of elements that go into a covalent molecule.
It's from atoms sharing.
Okay, it's from the atoms sharing electrons. Folks, because these atoms share electrons, the options are enormous. Carbon can combine with hydrogen in more ways than I want to give you a number for. Because I can have an alkane, I can have an alkene, I can have an alkyne, I can have an alcohol, I can have a carboxylic acid, and all of those are going to continue have a carbon-hydrogen combination in there. I can have an amide, an amine, an amino acid. I can have all sorts of things. They're all going to have carbon and hydrogen in there. Because we are sharing electrons, the options are astronomical for how all these elements can combine. Another example. Or set of examples. You can have carbon combined with one oxygen. We can have carbon combined with two oxygens. You can have hydrogen combined with one oxygen, or you can have hydrogen combined with two oxygens. Now, this one's a specific kind of oxygen, but the fact is when you start talking about your nonmetals and metalloids only, if your compound consists of nonmetals and metalloids only, you have a ton of options with respect to combinations. So I cannot do what I did with ionic compounds. If I was playing around with an ionic compound, I would have called this carbon oxide. But I would have also called this carbon oxide, because when I played around with the ionic compounds, the first element got its name and the second element got an ending IDE. Sodium chloride, magnesium bromide. Because they share electrons, I cannot treat them the exact same way I treated ionic compounds. Because there are multiple options for the same elements to combine. Neither of those are referred to as carbon oxide. Because simply by referring to them as carbon oxide, I don't know what combination you're referring to. I don't know if I've got a gas that is small enough then it can replace the oxygen within my body and kill me rather rapidly. Or whether I have a greenhouse gas, which can still kill you rather rapidly if you don't have any oxygen in the atmosphere, but they behave differently in how they kill you. This one suffocates you. This one replaces the oxygen in your system. There are differences. The length of time it takes are different. There are differences. So you cannot simply call covalent molecules by their first name, by the first element's name, followed by the second element's name ending in IDE. So with binary covalent molecules, we will use a prefix system. That describes how many of each element is present within the compound. If there is one, the prefix is mono. Now, a quick note about mono. Mono is only used on the second element. As a prefix. What that means is, for instance, those examples I gave you earlier, where I had one carbon on both of them, I would not have put the prefix mono on the carbon. But on that top one, I would have put the prefix mono with the second one. So it's mono is only used on the second element. It's never used on the first. So CO is carbon monoxide. Now, 2 is di, 3 tri, 4 is tetra. 5 gets back to the same thing we were talking with our alkanes, penta. 6 is hexa. 7 is hepta. 8 is octa. 9 is nona. And 10 is deca. Now, there is another note to add, and that is we will drop an A or an O from the prefix if the element begins with A or O. So let me go back to my original example of CO. We have one carbon and we have one oxygen. Technically, one means mono, and we would write our carbon. One means mono. And the second element gets the ending IDE. Now, we do not use the prefix for the mono on the first element. So that simply is carbon. And you will notice that our prefix ends in O and our element begins in O. So we are going to drop the O on the prefix and combine them to make monoxide. CO2, you have one carbon, you have two oxygens according to the formula. Again, the prefix for one is mono, and we have carbon. The prefix for two is di, and we have our oxygen, which we replace with an IDE. We never use mono on the first element. So this becomes carbon dioxide. You can have all sorts of combinations again. This formula has 4 sulfur and it has 10 oxygens. 4 is tetra. Then you have your sulfur. 10 is deca. Then you have oxide. So this is tetrasulfur decoxide. Only if it's a single, only if it's a 1. You will use it for all other prefixes. It's only for mono. Only time you leave off a prefix is if it's for 1 on the first element. Folks, that means that it's real easy to also interpret the names. No prefix means 1 sulfur. Tri means 3 oxygen. So this one is SO3. Binary covalent molecules state what they mean and mean what they state. The key to it is knowing your prefixes. Question, yes.
We still call water water.
You will still call water water. I know water could be dihydrogen monoxide, but it's water. And I know dihydrogen monoxide can kill you, but it's rather difficult. But water is water is water. The reason, let me explain why water, whereas everything else gets a specific name. The reason is we have, what I've been teaching you is referred to as the IUPAC system, IUPAC system. And the IUPAC system was developed. So no matter what country you're from, no matter what region you're from, no matter what school you went to, you could tell me the name of a chemical and I could understand it based on the IUPAC system. We don't do that with water because water has been water since early in the dawn of time. And while we may use slightly different variations, like aqua, it's still saying water. So if you say water, people know it's water. And that's why we don't use the IUPAC name for water. Whereas most of the rest of it, they used to have a different name for different compounds depending on where you live. This way we all use the same terminology. Questions about covalent molecules? So you got 4 types to know. The diatomics, Frankel-Hall. Their formula is that element with subscript 2, and their name is simply whatever the element's name is. You've got hydrogen with group 15 through 17. The formula will have the same number of hydrogens as would be the charge on that other element if it were an ion. But to name it, you just say hydrogen and whatever the other element's name is with the ending IE. Then we got into the alkanes. The alkanes are carbon and hydrogen only compounds. They have to meet the formula C subscript N, H subscript 2N plus 2. If they don't meet the formula C subscript N, H subscript 2N plus 2, it's not an alkane. And alkanes have a specific name that end in A. 1 through 4, you just got to know them. It's metheth-propute. But 5 through 10, their prefixes are the same as the geometric structure with that number. And then we got into the binary. Binary covalent molecules. Binary means 2. So there's only going to be 2 types of atoms ever. And with binary covalent molecules, because covalent bonds arise through the sharing of electrons, we have so many different options for the same 2 elements and the way they combine that we specify their combination in their name by using the prefix system. That is the covalent molecules. Now we're going to get into acids. Acids. We are going to encounter 2 types of acids. We will have the binary acids And we will have the oxy acids. Binary acids will be acids of hydrogen and group 15 through 17 nonmetals and metalloids. Oxy acids are acids of polyatomic ions. That is the difference between a binary acid and an oxy acid. So binary acid, I did it. You got means two atom. One of which will be hydrogen. And the oxy acids, the oxy is the giveaway because it's going to be hydrogen. Having fun today. Hydrogen with polyatomic that has an oxygen in it. That's how they got their names. Now, before I really get into naming these acids and the formulas of these acids, I want to explain what an acid is. An acid is a substance that when added to water produces an H plus. Now, breaking this down a little further, added to water. What that means is that these will be aqueous compounds, which we will represent as an AQ. So HCl, HCl aqueous. This first one is not an acid. The second one is an acid. They are named two different ways. In this particular case, HCl, that is hydrogen with group 17. So it is hydrogen chloride. HCl aqueous we know again is an acid, and we will talk about how, but it is called hydrochloric acid. So they are named differently depending upon whether it's an acid or whether it is not an acid.
Why is one acidic and one isn't?
Because one is dissolved in water. And it's only once it dissolves in water that, so let me explain by drawing a chemical reaction. If I have HCl by itself, it is a gas. That's what the G means. And I add it to water, which is a liquid. What happens is that the hydrogen of the HCl is going to dissociate so that it is no longer going to be attached to the chloride. So you wind up with Cl- in water, and we wind up with H3O plus technically, which you will see written as sometimes just H plus. They mean the same thing. So it's not until it's added to water that this hydrogen completely dissociates from the chlorine. And it's only once it dissociates from the chlorine that it becomes an acid. Does that make sense? So it has to have that dissociation. And that's why this is an acid, that one is not. Is because this one means that the hydrogen will have dissociated. Okay. So what we're really doing at this point is learning how to name. So let's talk about binary acids first. And let's start with the formula. If you have a binary acid, the formula will have the same number of hydrogens on the nonmetal or metalloid as would be the charge on the nonmetal or metalloid if it were an ion. Or an anion, I suppose, would work. The other part of the formula is that the formula will have AQ at the end. Now, the name. All binary acids have the same general formula. or same general name. It starts with a hydro, ends with ic acid, where this is the root of the second element. Because hydrogen is always listed first. So let's look at a couple of examples. We're going to talk about the acid of sulfur. What would be the charge on a sulfur? -2. That means we need 2 hydrogens. And then we're going to finish it up with AQ. That's the formula. Now let's look at the name. And I'm going to go up here and we're going to look at it based on what I wrote earlier. It's going to be hydro, sulfur, and it's going to end in ic acid. So that is hydrosulfuric acid. No. Binary acids, hydro is the first thing. Let's go with the nitrogen. What's nitrogen's charge? -3. So this would be 3 hydrogens. And we would follow it with AQ. And it would be hydro nitric acid. Binary acids are actually pretty straightforward. Again, binary means 2 atoms. So you're only going to use this hydroblankic acid if there's only 2 atoms, one of which has to be the hydrogen. Now let's get into the oxyacids. Let's start with the formula. The number of hydrogens equals the magnitude of the charge, or the number is what I mean by magnitude, the number of the charge. And then again, add AQ to the end. That's the easy part. Hard part unless you have your, well, actually, none of it's easy unless you have your polyatomics memorized. You gotta know your polyatomics or you're not gonna be able to name the acids. You gotta know the formula, you gotta know the name. So let's talk names. The suffix ate in an oxyacid or in a of a polyatomic becomes ic acid. Come on. Nope, no. As an aqueous compound. And if the polyatomic ends in "ite", becomes us acid as an aqueous compound. So we have our polyatomic ion. Ion name. Acid formula. Acid name. So if I have the polyatomic ion SO42 minus, what is it? Yes, it's sulfate. According to what I just wrote about formulas, the number of hydrogens is equal to the charge. Since it's got a 2 minus charge, it needs 2 hydrogens, followed by AQ. Since this ends in ATE, to name the acid, it becomes, not that, becomes sulfuric acid. With the ic acid. What is NO2 minus? It is nitrite. Because it has a -1 charge, that means it only needs 1 hydrogen, followed by aqueous to make the acid's formula. Because it ends in ITE, we're going to change that, and it becomes nitrous acid. Folks, if you don't know your polyatomic ions, it's going to come to haunt you.
would I have like a list of like?
Again, you're not going to get a list. But again, remember most of the ones through period, you need to memorize most of the ones through period 3. But then if you'll realize that period 4 and 5 look identical, you know the ones in period 4 and 5 too. Questions about, yes.
Do you ever have like a negative charge or like a charge to the acid on that?
There's never a charge associated with the acid. Because the number of hydrogens have counterbalanced the number of, it has counterbalanced the charge on the ion. So just a quick summary of the acids. Basically, it's all based off of the anion. IDE, the name of the acid is hydroic acid. ATE, it is just ic acid. And ITE, it is just us acid. And the number of hydrogens, no matter whether it's a binary, a oxy, the number of hydrogens is the same as the charge on the anion. Now, the last thing I wanted to show you before we move out of naming all of this is something that as soon as I get back to my office, I plan to post. There is and you can't read it, so that's why I said I've got to post it. There is going to be a PowerPoint. This PowerPoint, in this particular case, looks like it's going to help you with naming. I always have to figure out which one I'm looking at. And what it does is it gives you specific questions to ask. Does the formula begin with a metal or ammonium? If yes, it's an ionic compound. Then it says, does the cation always have the same charge? If yes, you just name the cation, you name the anion, and you are done. If when you got to does the cation always have the same charge, you say no, that's where you got to get the Roman numeral. You got to figure out what the Roman numeral is. Now, up here, when you said, is the first element listed a metal or ammonium? If you say no, that means it's going to be a covalent molecule. Then it says, does it begin with hydrogen? If it begins with hydrogen, then it's going to be, you've got another set of questions, and that is, does it end in aqueous? If it doesn't end in aqueous, then you name the hydrogen, you name the second element. But if it does end in aqueous, then that means you have an acid. And so there's another question. Is it binary or is the other part an element or is it polyatomic ion? And that helps you sort.
If up here, it says, does it begin with hydrogen, you said no. The question is it carbon and hydrogen only? Then it's now probably going to be an alkane. If it's not, then it's going to be something else. So this flow chart is there, and in that same PowerPoint, you also have a flow chart that will help you go from the name directly to the formula. So this is so I've got some things, and basically these are questions that as you're progressing, as you're learning to do all this naming and formulas, they will come in handy. Now, there are optional homeworks related to covalent molecules and acids, and an optional homework from last week related to ionic compounds. Those are great to give you some practice with a specific type. But on the test, they're all going to be mixed up, and that is why there is also the mixed set, so that you have the opportunity to learn to use this flow chart to help you go through the mixed set and figure out, okay, how do I go about this? You'll learn the process, in other words. Because basically you just learned 8 different styles of naming. Yeah. And that's a lot. Any questions? So, at this stage of the course, which is almost the halfway point, we have talked about the elements of and what they look like. How many protons does an element have? It's its atomic number. How many neutrons? Well, that's based on the isotope. How many electrons? Well, if it's neutral, it's the same as the protons, but if it's an ion, that's a different story. We've taken and we have explored the atom of the element and determined where every single electron is in that electron cloud surrounding the nucleus. So basically you were getting a gist, an idea of the atoms and the elements and what they could do. Then what we started doing is we started combining those atoms and elements to form compounds and ions and all sorts of things. And we talked about the names and formulas of those compounds. What we're about to do, starting Monday, is we're going to start combining compounds to make reactions. So basically, folks, what we've been doing is building it. Back in grade school, you started by tracing your alphabet. We started with our alphabet, the elements. Then you started combining that alphabet to make words. We combined our symbols to make compounds, which are our words. After you got where you were going through those words, then you combine those words to make a sentence. A reaction is our sentences. And so on Monday, we're going to start writing sentences for our chemical reactions. Otherwise, I will see you on Monday. Well, actually, we've got to do a little bit more on formulas first. Then we get to the sentences.